What's going on, ladies and gents, and welcome back to a brand new video. This is Web Dev Journey, and today we're going to be talking about elastic IPs. Like we left off in the last video, we're going to be talking about VPN, scaling with elastic load balancers, and also DNS with Route 53. So let's just get right into it so we don't waste that much time, because this might be a long video. So anyways, since we told AWS that our instances could have a public IP address, you can have a private instance. It's going to have an IP still, but it won't be public. But since our instances are public, they now have public IP addresses. And the way they get those addresses or the IP addresses is because AWS randomly assigns them to each one of our servers. And now that our servers have public IP addresses, they are accessible from the public internet through the internet gateway, which we talked about in the last video that they created for us. But the only catch with these public IP addresses is that if you stop the instance, which is like pulling the power plug from the server, and then you start it back up again later, it's going to go to Amazon's pool of IP addresses and get a new public IP. Now, if you hard coded your IP addresses anywhere, such as in your DNS records, which we will talk about that in this video, then you'll need to go through and update everything with your new public IP address. Now, if this happens randomly in the middle of the night, which it really can, especially if AWS is trying to recover an instance due to hardware failure, then your site's going to be down until you get up and make your DNS changes. It's kind of like waking up in the morning, going out to check your mail, and realizing that the post office changed the house number on your mailbox. So if you need this public IP address to stay the same regardless of what happens to this instance, then you'll need to request an elastic IP. Elastic IPs come from Amazon's pool of IP addresses, but they're bound to your AWS account instead of being temporarily tied to a single running instance. You then assign your elastic IP to your running instance, but if you choose to terminate your instance, this elastic IP is going to stay on your account and can be assigned to another instance in the future. But because the internet is running out of IPv4 addresses, there are precious resources, okay? And Amazon will penalize you with a small fee each month for keeping elastic IPs on your account that aren't being used. So if you terminate your instance, make sure you release the elastic IP if you have no further need of it, because you will be billed for it later on. So in the last video, we actually left off on VPC and the elastic binding for our NAT gateway, because we didn't really have an elastic IP address. So the way you would actually do that, I don't even know why I clicked up there, is down here. Where is it at? In our right here, elastic IPs, you would just allocate a new address, and this will give you an IP address or elastic IP address that you will. Look, let's just do it. I'm going to allocate a new one. It will just give it to us. Allocate, and there you go. That's my elastic IP address. And it gives it to me right here. And then you could just notice that we don't have an instance or a private IP. It's because we haven't bound this to anything. I'm going to just release address. Now, there's another way you could do it, and that is from your EC2 console. Let's wait for that. On the left, under network and security, here's your elastic IPs. You could click again, allocate elastic IP address, and click on allocate, and you'll get an IP address or elastic IP address. So if you already have like a ton of these, I would recommend you, looking at what they're actually associated with, and if they're not associated, just release it. You will be billed, like I said. All right, let's actually bind this to an instance that we have. So select it, go to actions, and then associate elastic IP address. We want to do it in an instance, and then in the drop down, I'm gonna do web server 1, and also your private IP address, which you only have one, and then allow. Hold on. Oh, I was just looking at this. I was like, no, we don't want to allow it to this is basically, you could share this IP address. I don't want to share it. It's just for this one server. So let's just associate it. And now we could actually check what's going on. So over here, let me see my instances. Web server 1, you can see that our IP changed. Now, if you were logged in an SSH, you would have to log. It would have terminated your connection. You would have to log in doing the connect and doing this new one right here. Now, after all this, I do want to go to VPN. Start talking about VPN. VPN. I'm pretty sure if you work for a company and you work remotely, you go through a VPN. So I'm pretty sure you know what a VPN is. I'm just going to go really fast on Amazon's services for VPN. And there's actually two main use cases for using a VPN, or if you don't know already, a virtual private network with Amazon Web Services. So the one that is most relevant to developers is called AWS Client VPN. And it actually allows you to use a VPN client on your home or work computer to establish a secure connection with your VPC. And there's actually a diagram from last time. Let me put it up right here. Let's go to the second one right here. So if you went with a VPC configuration where you have a private subnet and you place your database instances inside of that private subnet, then sorry, in my head I'm trying to like think about it. I'm like, okay. But since the gateway only has a doorknob on the inside, it'll also prevent you from establishing a connection with your own database server from work or home. Now, we talked about this in the last video where there's that gateway and I used that door reference. Remember that? So that's what I'm talking about right now. So you wouldn't be able to use your database editor installed on your machine, such as SQL Server Management Studio or MySQL Workbench, as most of us already use that one anyways. So you wouldn't be able to use any of those. And if you need to develop your source code locally and connect to a development database that's in a private subnet, your code wouldn't make that connection. So there's actually a way around this, and that is to use AWS Client VPN. And let me actually show you what's going on with VPN right here. And this is going to establish a secure tunnel from your local computer directly to your VPC. So now you've created a secure side door into your VPC that only you and other authorized users can access. And the other main case for a VPN is AWS is called what was that? Oh yeah. Site-to-site VPN. So a site-to-site VPN is one of the ways that you can bridge your existing on-premise data center network with your VPC. And we could actually take a look at that with one of the diagrams. And this is scenario 3 on this case. So scrolling down over here, you would actually use a site-to-site VPN to securely move your data up to AWS as a part of a cloud migration. Or you would use this in a hybrid model where some of your on-premise infrastructure continues to serve your applications, but this way you'll start actually using more AWS services to support your on-premise application. So yeah, just think about that. So yeah, those are the two most common VPNs that we'll be using, or you'll be using. So another thing I do want to talk about is Elastic Load Balancer, okay? And I don't know if you remember, but I did talk about auto scaling a couple of videos back, and I had you imagine that you were at a grocery store, and then when the checkout lane started getting long, auto scaling would open up more checkout lanes by scaling up the number of instances. Remember that? I'm not too sure. But sometimes when lanes start getting really, really long, the grocery store will have an attendant walk up and down in front of all the checkout lanes so that the attendant will direct you to which checkout lane you should go to. So in the networking world, that attendant is actually called a load balancer. And let me pull up, yes, you guessed it, a diagram. And look at this. This is pretty. Oh man, I'm not a designer, sorry. So a load balancer actually splits up the incoming traffic and balances it among your healthy servers. It's a key component to horizontal scaling, and in AWS, this is called an elastic load balancer. No, obviously this isn't a load balancer. It's a USB hub, but this will actually make it easier for me to show you how exactly or what exactly load balancer does. So you actually point your traffic right here, this cord, you point it to your load balancer. And that load balancer will then forward that traffic onto any healthy servers. If you need to scale up, you add an instance and it'll start directing a share of the traffic to that new instance. If it detects that one of the servers isn't healthy, it'll stop directing traffic to that instance. And you could also tell it to take a healthy server out of rotation, such as when you need to perform maintenance on that server. If the grocery store attendant knows that the cashier on lane 1 is about to go on break, they'll stop directing customers to lane 1, and that cashier will check out the remaining customers and then close their lane. Likewise, a load balancer will stop sending new connections to a server and let it drain its remaining connections before actually going offline completely. So let's actually create load balancers in AWS. I hope you actually got the diagram. I think it's pretty good. So in AWS over here be on the side, we're going to click on, where is it at? Scroll down some more. Load balancers right there. Create load balancer. Okay, let me explain what's going on these two anyways. So the network load balancer are really fast, but they don't have many features because they achieve that speed by not looking too closely at the traffic coming in. Application load balancers are great for web traffic because they'll look at the incoming traffic and route it based on a set of rules. So let's actually create an application load balancer. We're going to create that. For name, I'm going to type in test ALB. We're going to leave the listener section as its default, but these are the ports that you want your ALB to listen on and forward to your target servers. For availability zones, we're going to be doing US East 1A and also doing the hard public. It already knows. Obviously, for your VPC, you could change it to the default one if you want to, or the VPC demo that we've created. So I'm just leave it as my VPC demo. It's going to go into subnet because the only subnet inside VPC demo is actually public A. Remember that. So next, I see it's giving me an error because it needs to be in at least 2 subnets, which we only have 1 subnet. So let's switch it over to default and then choose our availability zones. So 1A and 1B. So now you could actually hit configure security settings. And so we're not going to be setting HTTPS up right now. This is what it's asking for, but we're not going to be setting that right now. So we're going to just click on next. Load balancers actually use security groups just like EC2 servers do. So there's a filter on the internet like coming into your load balancer. I think I said like. I meant to say there's a filter on the internet line coming into your load balancer, just like your EC2s. So we're going to actually select create a new security group. Now I'm going to leave all of the default as is, but for any ports that your load balancers listen on, you also need to allow those same ports in the security group. Remember we did that in the last or the few videos before this one, where we had to allow security groups or ports to listen to our EC2 instance, so that way we could actually use it or see it in public. Let's click configure routing now. Okay, now this. So load balancers route their traffic to a target groups, which include your target servers. So for a name, I'm going to say web servers. Now, these default settings say that ALB is going to route its incoming traffic, which is coming in on port 80 to port 80 on the target servers. Now, ALB will use health checks to determine that a server is healthy before sending traffic to it. You might have a specific page in your application that you want ALB to check, but the root of your site is fine, so leave these settings as is, and then just click on Next, Register Targets. Now, on this page, we're actually registering the target servers to the target groups that we just created. So we're going to just click both of our servers or instances and then add to registered. And now they're registered, and we're going to just say click review. And lastly but not least, let's actually create it. Oh boy, here we go. Successful. Let's close it out. So down here, let's actually click on listeners tab, and under the rules column on the port 80 line, we're going to click on the web servers group, target group. Down here, we're going to click on targets, and since we just created this load balancer, the status of each of these is going to be target registration is in progress and initial. This basically means where the health check hasn't run its complete course yet, so we do need to wait a few minutes for it to actually run its course. So I'm gonna just pause the video, and then after a few minutes, it should say healthy on yours. So we'll get back to that. All right, I'm back, and now it's healthy. I hope yours is healthy as well. Now what we could do is actually go back over here, click on load balancers. And down here in the description, what we're going to be doing, let me actually pull this up because it's annoying, is copying this DNS name. Copy that, and let's actually paste it in our browser. And what do you know? It works. What? So our load balancer is actually shuffling the incoming port 80 traffic to both healthy servers. We did it. We completed it. We did an elastic load balancer. Awesome. Give yourself a pat on the back. This stuff isn't really hard. It's just, you know, no one takes the time to actually understand these things. So now we're actually done setting up our application load balancer to balance the web traffic to our healthy instances. But the thing is, we don't want our users going to that long, ugly URL that AWS gave us. We want to use our own domain name, DNS. This is where DNS comes in. So our domain name system, it's like a phone book of the internet, let's say. It takes a domain name like youtube.com, and it looks up the IP address, because telling your colleagues or your friends or whatever to connect with you at 208.65.153.238, it doesn't sound good at all. It doesn't sound as good as saying, hey, connect with me at youtube.com, So AWS has a DNS service that they host, and it's called Route 53. And I already told you about this, and today is the day we talk about Route 53. So it's actually easy to remember because the internet standard is that all DNS servers communicate over port 53, hence Route 53. Route 53 isn't just a regular DNS hosting service like GoDaddy has for linking a domain name to an IP address. It has additional features. It has way more features than GoDaddy, and routing options for traffic that's headed to AWS servers. And that can help you with scalability and increasing the uptime of your app. So let's actually go in and mess around with Route 53. So on services, obviously you already know, type in Route 53, first one. So you could actually create domain names with Route 53, or if you already have some parked, I actually do have some parked in GoDaddy. You could use those instead. So if you already, like I said, if you don't have any, go to domain registration, register some if you want to, or DNS management, which I'm going to do right now because I already have one, like I said. So let's actually create a hosted zone. Click on that, create a hosted zone. Right here, our domain name. So you do have to have a domain name. And I have one, and it's called fruitlesscoder.com. My comment, I'm gonna just say GoDaddy. GoDaddy. I'm just say GoDaddy. That way I know it's in GoDaddy. And I do want it public, so let's create that. And then we're going to set up a record. So this is the place where we actually want to create our record sets. And we're going to be creating a record and a record, so that way we could point that to our load balancer. So let's create record set over here. Not there. So type is going to be alias. You do want to do alias, and you want to enter in the load balancer that we created, which was test ALB. And then we're going to just simply say create. Now we could create another one, and we probably should. So let's create another one just in case. The name is going to be www. Or it already has a dot. www.fruitlesscoder is going to be a again, and that's it. Just create. We're not. Oh, my bad. And we could actually. Sorry, I forgot to do the alias. We're gonna do alias, but this time we're going to be pointing it to our fruitlesscoder.com because it has the exact same alias ALB that we have. So we could do it this way if you wanted to, where you could just target it to your load balancer. But since Fruitless Coder already does that for us, I'm just going to be pointing it to fruitlesscoder.com and then hit create. Now we have fruitlesscoder.com and www.fruitlesscoder.com. So now www.fruitlesscoder.com points to fruitlesscoder.com. Now this might take several hours depending on how you set it up for your DNS to update itself. But usually this happens within, 5 to 15 minutes maybe. So I'll let you know once we're all set and ready to go. So I'll just pause the video and then come back. All right, guys. Now that I waited a bit for this DNS to refresh itself, it's time to actually go to my page, Fruitless Coder. Oh, by the way, let me know what you think about fruitlesscoder.com. So let's actually go to fruitlesscoder.com. Let's see what happens. And we got our Ubuntu Apache 2 server. Awesome, it's actually working. So this actually means that my domain at Route 53 is now pointing to my application load balancer, which is sending me to one of my healthy servers, the ones we created. Oh, and plus, if you don't know what to do, let me actually go through the whole thing right now. So if you do have, let me get rid of this and this. So if you actually do have your own stuff at GoDaddy or something like that, so what you need to do is actually change your DNS server names or name servers as they're commonly used, I guess, to Amazon's name server. So let's go back to hosted zones. And right here, this is the one I want to change my DNS name server. So what I would do is actually click this radio button right here, and it'll give you the name servers right here. 4 of them for this matter. I just use the first 2. Now, I'm actually going to bring up GoDaddy. I do have to block out some things. So in my DNS management down here, obviously the records, they can't provide the records because they're not being managed by them. It's being managed by my AWS account. But down here on my name servers, this is where you're actually going to change those. These are going to be defaulted to GoDaddy's name servers. We don't want that. We actually want the name servers that they gave fruitlesscoder.com. And they're right here. So all you do is just copy these and paste them right there. As you can see, they're exactly the same. You see AWS DNS 38.org, ANS DNS 38.org. You just copy and paste, and that is it. So that might take some time as well. And then once you're done with that, don't even worry about it. Like I said, you could go to record sets, create records if you need to, like we did right now, and you're pretty much golden. Anyways, this is probably one of those things that I might actually get into detail later on in the series, because we all use this to actually host our applications onto the public internet with a pretty name. Obviously, you could just use that IP address that Amazon gives you and, be done with it. You don't have to even buy a domain name. But what's the fun in that, right, guys? What's the fun in that? So that's actually it for this video, guys. I hope you enjoyed it. I know it was a lot of information, a whole lot of information that we just went over. So please relook at the video again and again so that way you get the concepts of this topic or the series, AWS, because it's very important, especially the DNS. And if you would like me to make more in-depth tutorials on certain things, just let me know and I'll actually do it. Right now, like I said, I've been saying all this time, we're just going over the basics of AWS, so there's no real reason for me to go into depth on any of these services like DNS or web application or load balancers or any of that. So thank you guys for spending some time spending your time watching my videos. It really does help me, and it really does mean a lot to me. If you like the video, please subscribe, hit the like button, and also comment down below on, first of all, what you thought about my domain name, fruitlesscoder.com. I have that in the link in the description down below as well. So thank you guys, and I will see you in the next video. Bye.